Woohoo! Welcome back. Tonight we're going to be working with function notation and working with a very particular construction called the difference quotient. Dun dun dun! So this right here is referred to as the difference quotient. And although that can be a very intimidating title or name for something, it's really just mathematically describing exactly what's going on without giving you a lot of information. It's telling us there's a difference, so there's something subtracting, which we can see. And then it's telling us there's a quotient, which means there are two things being divided, which we can see. So it's really just the subtractee dividey thing. Except we wrote it in math speak. So difference quotient, subtractee dividey thing. This is a difference, you'll notice, of two functions, f of x plus h minus f of x. So we've got, it's not really two functions, it's one function, f, but it's evaluated at x plus h and at x. And then down in the denominator, we just have an h. And we had to make a note, by the way, keep in mind h is not 0. It turns out that the denominator didn't start out as h. And this is just extra information if you're interested. It started out as x plus h minus h. Oh, no, it didn't. Oh my goodness, that's not helpful. That time my hand and my voice were in league saying the wrong thing together. Oh my goodness. It's x minus h minus x, which you can see right here. There's the x plus h, there's the x. And so when you take x plus h and you subtract out the x, all you're left with is the h. So this right here is where the h came from. And it turns out, and I know this may be hard to see right now, but this is just the slope. This is the formula for slope. y2 minus y1 all over x2 minus x1. And I know, and I'm going to do that, so everybody's thinking about other things. But these are the two pieces that makes this just, oh my goodness, a lot of ink. But that makes this just a slope. But for right now, when you're just first learning this, you don't have to worry about the slope. You don't have to worry about anything. The big question is going to be learning how to evaluate this. So practicing, and this is going to take a lot of practice. For some of you, it may come easily, but for most people, I'm going to guess it's going to take a couple tries. So be really gentle with yourself, ask lots of questions, ask for more examples, ask for help, and just keep working at it. This will be something that you've got about a year to get good at, because this is something we're going to be doing in calculus. So let's go ahead and get started. So the first thing we've got is, I'll remind you, we have function notation, and f of something equals that thing plus 3. Right? F of x equals x plus 3 means f of whatever's in here means whatever's in there comes out and you add 3. So this function is basically just the function that says whatever you get, add 3. Okay, so we start off with f of x. We've got that. That's this part right there. What we need to find is f of x plus h. And you might remember from the last lecture, we were already talking about x plus h. And I was like, where did h come from? And the answer is, you don't know yet. But it came from somewhere really important. And we remember it's not equal to 0. But it turns out sometimes it's very, very small. So whether that's interesting or not, feel free to tuck that piece of information away. So f of whatever f gets is going to be that thing plus 3. So f of x plus h is going to be x plus h plus 3. You just add 3 to it, which is just x plus h plus 3. Okay, now this is, so I don't know if everybody here who's watching this has made pancakes, but the best way to make pancakes that I know of is rather than just mixing everything in a single bowl, which is fine, makes delicious pancakes. But if you would like your pancakes to be extra fluffy, then you make one bowl that has the wet ingredients and another bowl that has the dry ingredients, and at the end you bring them together. The difference quotient is just like this. We want, here's the difference quotient, and I'm going to write it out again so you get used to it. The difference quotient is a formula. Now, you do not have to have this memorized for this class. If I want you to calculate this, I will ask you to calculate it. I will give it to you like this. However, by the time you get to calculus, you're going to have to be used to this. So if you have a hard time memorizing things and it's a good idea to get started now, I encourage you to get started now. So let's get back to our pancake recipe. Our pancake recipe is that I'm going to come up with f of x plus h. And in fact, I've got that right here, right? And then I'm going to come up separately with f of x, which in fact, we don't have to do anything to get because it's right there. It's the original formula. It's the plain formula with nothing fancy, right? F of x is just whatever the formula is. F of x plus h is suddenly, ooh, we got h in there. It's so fancy. So we got the fancy one, we subtract the plain one, and we divide the whole thing by h. So what does that look like? Well, it means I need space for my fancy one, and then I'm going to subtract, and then I need space for my plain one, and then I'm going to have an h to the denominator. So if you think about it, whenever we're subtracting expressions, it's a good idea to give ourselves some parentheses. I tend to use brackets just because some of these get really big and complicated. So I like brackets when things get complicated. So let's take a look. Okay, so for my plain, my f of x, that's whatever's given originally. F of x is just x plus 3. So x plus 3 goes in here. That's the plain version. Then I got the fancy version right there. That's my blue version. X plus h plus 3. And then I remember to divide the whole thing by h. And again, you don't really know. I kind of waved my arms around and said, oh, look, it's a slope. And oh, look, and I haven't told you anything really yet. But it is a slope. It is going to be something called the derivative eventually, once we teach you a few dozen other concepts. So it's coming. It's very exciting. Calculus is on its way. Once I get this written out, then when you're subtracting, remember the subtraction only affects the expression that comes after. So I can write x plus h plus 3 out. It just comes right out of its brackets. And then remember this opposite sign or -1, depending on how you like to look at it, it's either taking the opposite of this or it's multiplying everything by -1. So I'm going to take, and I get the opposite of x minus 3. Make sure that minus goes all the way through. That's a tricksy, tricksy little guy. All over h. So you'll notice that the x's cancel. And in fact, this plus 3 and this minus 3 cancel. And I will tell you a secret. For a lot of these, everything except for the h's cancels. It's kind of cool that way. And in this case, all I've got on top is that lone h. That's the only thing that sticks around. Everything else cancels. There's the h in the denominator, and the whole thing equals 1. Why? Well, as I said, this has to do with the slope. And if we have y equals x plus 3, f of x equals x plus 3, y equals x plus 3 is its xy equivalent. If this is in slope-intercept form, what is the slope? The slope is 1. So, you can go ahead and giggle because I have now shown you the world's hardest way to find the slope of a line. But we did do it. Okay, so let's go ahead and try the next step. Okay, you may want to pause the video because we're going to do the same thing but with a much more complicated f of x. Dun dun dun. And I know it's a lot. It really is a lot. So you may want to take a break. You may want to practice some more before we go on. Oh, you can see what's going in the next video. This is preview of the next video, but we don't need that right now. So let me move that out of the way. Okay, so again, you will not have to memorize this formula. I will write it out for you. What we need to do is we need to find f of x plus h minus f of x all over h. And again, this is the formula for the slope. And at this point, you would look at this and go, wait a minute, what are you even talking about? That's not a line. And the answer is, I know. In the future, in calculus, we're going to look at slopes of all sorts of things. And the big secret is it's always the slope of a line, but sometimes you can use slopes of lines to kind of approximate slopes of other things, which is kind of cool. But if you want to know more, you're going to have to come talk to me in office hours or just wait till you get to calculus. So for right now, we're going to say, well, it's this weird thing like a slope, except this is a parabola, I know, and whatever that means. But we're going to go ahead and break this down, and I'm going to remind you, this guy, the difference quotient, the subtracty dividey guy, has a fancy part, and it has a plain part. Oops, sorry about that. So let's go ahead. I've got f of x. So f of box equals, f of x is 2x squared. So that's 2 box squared minus 4x minus 4 box plus 5. Okay, so f of pink box is 2 times box squared minus 4 times the box plus 5. Okay. F of x plus h. This is the fancy one. Ooh, isn't it fancy? And I'll remind you, before we get started with that, before you get worried, the plain one is already worked out for you. So this part is already done. Thank goodness. So really, you only have to do the fancy piece. Okay, so we're going to do 2, and then x plus h. Remember, these two go everywhere there was a box or there was an x. X plus h squared minus 4 times x plus h plus 5. So effectively, what we're doing with this function notation, is we're taking an outside function and we're sticking a little guy, a little fancy guy, x plus h, into the function. So we're making like a combination monster function. And we do love monsters, right? Okay, so, dun dun dun, x plus h, the quantity squared. We're going to have to actually work that out. Now, you need to use FOIL. You may need to use the formula for a perfect square. So somewhere on the paper, I'm going to have to remember, okay, wait a minute. So I'm going to do a little inside, and I've got x plus h squared equals x plus h times x plus h. Okay, so that's going to be x squared first plus outer xh plus inner hx plus h squared, right? Okay, so that's x squared, and hopefully at this point you're like, oh, that's right, you combine these two xh plus h squared. Remember that perfect square formula? There we go. So I know that x plus h, the quantity squared, this guy, is going to be x squared plus 2xh plus h squared. And I know at this point, a lot of folks are like, oh my goodness, there are so many moving parts. And I know these are like the most complicated pancakes ever, but just imagine they're going to taste so good when you get it, or something like that. Okay, so back to f of x plus h. So I've got 2x plus h, the quantity squared, minus 4x plus h plus 5. So I've got 2 times x plus h, the quantity squared, is x squared plus 2xh plus h squared. Do you have to write this all out? No. If you have this memorized, you're golden. You don't have to write it out. Okay, minus 4 times the quantity x plus h plus 5. Okay. Now it's time to multiply out. 2 times each of these. Now this is a lot of work. It's easy to get really tired in the middle. Make sure you double check that you've multiplied by 2 every single time. So it's 2 times x squared plus 2 times 2xh plus 2 times h squared. So far so good? Okay. Then the minus 4 goes through. Minus 4x minus 4h. And then that plus 5 is just sitting on the outside. Okay, let's see what we got. I got 2x squared plus 4xh plus 2h squared minus 4x minus 4h plus 5. Now here's the bad news. The bad news is that usually nothing here will simplify. Yeah, it's just the way it works. Okay, so this is our fancy one. Let's remember, with the difference quotient, we got the fancy long one minus the simple, lovely little yellow one there. So, putting it all together, f of x plus h minus f of x all over h. And you need a lot of paper for this. Pardon me, Godzilla. You need a lot of paper because we got to fit this whole thing in. Okay, so it's going to be the blue one minus the yellow fancy one, or the yellow plain one, sorry. So, what is the yellow one? Let's go back up to the top. The yellow plain one, f of x, is 2x squared minus 4x plus 5. No frills, the boring basics. 2x squared minus 4x plus 5. Now, should I leave it just written like that? No. Gotta put my brackets in. I got h in the denominator, and then, oh man, this whole thing's got to fit in here. 2x squared plus 4xh plus 2h squared minus 4x minus 4h plus 5. Oh my goodness, I almost didn't get it in. Sorry about that. Like I said, you need a lot of paper. Okay, we're getting there, though. We're getting there. We're almost there. You hear Godzilla? Godzilla, here's my little support carnivore or omnivore. Okay, now I'm going to take a moment and write this all out. It is very tempting at this point. You're probably exhausted. You just want to be done. But be really, really careful because this problem depends on you really keeping track of all the little details. 2x squared plus 4xh plus 2h squared minus 4x minus 4h plus 5. Okay, so that comes out. The fancy one comes out exactly as it looks. Now, the plain one, remember this minus is going to go all the way through. Minus 2x squared. Minus a minus, plus 4x, minus 5. Now, do you remember what I said about what happens? And at which point you say, you've said a lot of things. I don't know which one you're thinking of right now. We're not mind readers. So here's the thing. Anything that's just x's, like 2x squared minus 2x squared. 4xh doesn't have a friend. 2h squared doesn't have a friend because it's got h's in it. Minus 4x plus 4x. I'm going to use 2 dots for that one. Minus 4h, that has an h in it, so it sticks around. Plus 5, minus 5. So all we have left up top are 4xh plus 2h squared minus 4h all over h. Everything that doesn't have an h in it cancels out. Isn't that nice? It's so cool. Okay. So what happens next? So what happens next is we have to cancel the h's. It's not a good idea to try to cancel them in this form. So what we're generally going to recommend is you factor out an h. Can you see this is amazing? It's like every single skill you've learned in this class so far goes into this one problem. It's pretty cool. I'm going to factor out an h. So if I pull the h out of this one, I've got 4x left there. Plus, this was 2h squared. It becomes 2h. And minus 4h becomes minus 4. And then I can cancel the h's and end up with 4x plus 2h minus 4, which is spitting distance from the derivative. Basically, that, if I cover up the h that's left, that's the derivative. We have basically just done calculus. It's pretty cool. Okay, that was a lot. I encourage you to take a break. You may need to watch this again. You may want to ask me for more examples. I've posted more examples, homework solutions, and I'm happy to do more of them for you because this really is a skill. It takes a lot of work to get right. Some folks are going to get it right off the bat. That's lovely for you, and I'm very happy. But if you don't get it right away, just be gentle. Know that it will happen. It just takes a lot of practice. And I am right here happy to help you because this is the key to calculus right here. So we are almost there. I can taste it. But right now, hopefully you're going to taste a tasty snack and something nice to drink and, give yourself a nice treat because you made it through something really rough and I'm really proud of you. So, math on, you're amazing. Woohoo.